little parabola, right? You don't have to write this down. And then what if I did, take that parabola and I wrote minus 10 in those parentheses. Which way would it take that parabola? Up 10, down 10, right 10, or left 10? This would go right 10. It's kind of that opposite. When it's in the parentheses, it's going to go the opposite direction. What if I did, and then plus 3? Then it's going to make that go up 3. Would that change if it was like this? This takes then the square root graph that looks like this. Pew! Would it still go right 10 up 3? Yeah. What if I did this? X minus 10 cubed plus 3. So it's this graph. Would that still go right 10 up 3? Sure would. What's our other parent function? Oh, yeah. What if I did that absolute value? Oops. Absolute value. Would that still take the v right 10 up 3? Sure would. Ooh, what if I did this? What would that negative do? Whoosh. Exactly. What if I had this, which is like this one, woo, and then I went like that? What does that one do? It goes like that, right? Okay, what if I had this, and then I went like this? Whoosh. Yeah, so it's just changing its direction. What if I had this guy, and then I went like that? It's just going to put it down, right? Okay, so all we're going to do today is, if we take a peek, I'm big on just using arrows with describing what's going on. The negative sign reflected my blue parent function over the x-axis. And then what do you think that 3 did? It took my x cubed and it went like this. And how I describe it is it just gets skinnier. When that 3 is here, that is just making my graph skinnier. Anyone know what that number could have been to make my graph a little wider? Oh, okay, let's go take a peek. So if I'm saying this was my original of x to the third, here's x to the third. Mr. Reichert, we are saying 3x to the third is going to make it skinnier. Would you agree red is skinnier than blue there? Okay, and then Reichert, you said if I did a 1/2 x to the third, it's going to be a little wider. Would you guys agree green is a little bit wider? I want it to be a lot wider. What could we do to make it a lot wider? 0.1 x to the third. Much wider. Go even wider. 0.001, he said. What did you say, Thomas? What did you say? What we're finding is when this number is bigger than 1, it's going to get skinnier. And when it's less than 1 but bigger than 0, right? When it's that decimal, still positive, it's just going to make it wider. And that's the word that we can use. So I don't need sentences, guys. I want some arrows. This 3 made it skinnier. That negative reflected over the x-axis. That's all I'm looking for. So let's just practice these 2 problems, and then we'll be good. This says use the graph of the parent function, but we're going to do this in our head. These 3, a, b, and c, refer to x squared. Okay, so I can show you what the x squared looks like, and you guys know, what does x squared look like, that basic graph? It's like a U. I love that. A basic x squared graph looks like a parabola. Boom. What is that 0.2 going to do to my parabola? It's going to make it wider. Let me show you. If we went y equals, oh gosh, I just got rid of that one. Here's x squared. If I do 0.2x, whoops, and I was supposed to, oops, I'm not writing this right. 0.2x, and I square that guy. Does red look wider? Yeah, so you guys, I'm good with just a little arrow and saying that 0.2 is making my x squared wider. What's going to happen in these parentheses if I did -5 and then a -2? Where's this shifting it? Right how many? Right 5 and then down 2. Let's go double check. Is this going to go if I did x minus 5 and I square it and then I do -2? Does it look like the origin went right 5, 1, 2, 3, 4, 5, and down 2? It's the same U, they just shifted it. Sound good? What is this 3 going to do to my cute little parabola? It's going to make it skinnier, narrower, however you want to say that. Skinnier. And what's that +6 going to do? It's going to go up 6. Why it's not going left to right is because it's not in those parentheses. Loy, you good with that, buddy? Yeah. Great. So I'm not looking for crazy deets. Here's my original x cubed. This one's kind of cool. If I go x cubed on this one, what is the absolute value going to do to that? Makes it all positive. What'd you say, bud? Yeah, exactly. He goes, oh, literally, my other arm's going to go up. Let's do it. Absolute math, right arrow. And I said the absolute value of x cubed. Check that out. Blue is actually underneath red right now. My blue is here. My blue is like that. And then just like Labeo said, this part got reflected up. So boom, there's my x cubed graph. So I guess, how would we say that? All my y values became positive. I love it. All y values positive. That's what absolute value is going to do. Okay, again, I'm going to get rid of that. What is a negative, and then what's that 2 going to do on this next one? What's the negative going to do to this x cubed graph? Reflected over the x-axis. Then what's that 2 going to do? Narrower, skinnier. Agreed. So I'm just going to show you. Boom. Blue was my original, I believe. Blue is my original. Red is reflected and a little skinnier. So I would just put a little arrow, reflected over the x-axis. Don't just say reflected. Don't just say flipped. We got to say over that x-axis. And then the 2, it's going to make it skinnier. Ooh, what about 0.75 out front? It's going to make it a little wider. Well done, because it's a little less than 1. It's going to make it wider. And then plus 1 in my cubed is going to go left 1. Here. Whoa. Practice what I'm actually asking for here. It says, describe the transformation. If I were you, I would say, all right, what's this 2 doing, you guys? The 2 is making it skinnier. The minus 3 is making it go right 3. I'm going right 3. Here's what I would want your sketch to look like. This is an x cubed graph. We've got to know this is an x cubed graph. The origin needs to go right 3. So I want you to go boom, 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 right 3. And then I'm good with a sketch from there. I know the graph looks like this and it needs to be a little skinnier. So I'm just going to be like, okay, it looks pretty skinny. All right, I'm okay with, I'm good with just that. I'm good with a sketch. I'm just saying that we don't have to be too specific about this. Let's go, let me show you what I'm expecting. Let's say, let's go to 19. What I'm expecting in 19. It says, describe the relationship between the graphs, and they want us to graph both of them. You guys, f of x is root x. I want you to just sketch that parent function that's like this. Pew! There's my original function. Then what's that g of x going to do to it? What's happening with the negative? The negative is going to make it reflect over the x-axis. And then what's that plus 3 going to do? It's not underneath the square root. That's a good call. So it's going to go up 3. So what I want then is that origin is going to go up 3. So I'm going to draw that new little point there. And then instead of going up, you just said it's going to be reflected. So it's going to be like this. Beep. It's going to be opening up instead of down. Yeah, it's if we look at 29, because I think 29 is kind of hard. 29 kind of has 2 things going on with it. I want you to actually just think about 29 as this first, without those absolute value bars. What's x squared look like? Careful, absolute value of x would be a v. X squared, because I kind of got rid of those bars for now. It looks like x squared, right? And then what's that minus 4 going to do? Oh, okay, yeah, I understand these confusions. Act like these bars are not going to move us. If those bars aren't there, we just have an x squared whoosh, down 4. So this is going to go down 4. We're going to go down 4. And you know what? Let's just get rid of those bars in general. What's that x squared going to do then? Well, it's just going to look like an x squared. So I'm okay with you just sketching that. Let's get rid of those bars in general. I'm good with it. Okay, on 32, what's that going to make us do? What's the parent function is just the v. What's the minus 2 going to do? Take the v to the minus 2 is going to make it go right, left, up, or down. This minus 1 is going to make us go down 1. Yeah, because it's in the bars. What about this 4? It's going to make that v go skinny. Exactly. What about that minus sign? It's going to reflect over the x-axis. Whoa, there's a lot going on here. There's a lot going on. So my original v, we're going to go take it right 2 and down 1. We went right 2, then we went down 1. Then I need to reflect it. Whoosh. Then I need to make it skinnier. Whoosh. So I'm just going to say, man, this has got to be skinny mini. Reflected.